it tells us if a to the u equals a to the v, then u equals v. What that means is if you have the same base on each side, then you can set the exponents equal to one another. So when we solve these equations, we will try to rewrite them so it's the same base on each side, and then we can drop the base and say the exponents are equal. Alright, so our first example. 3 to the x plus 1 power equals 81. So I need to somehow rewrite this so that they each have the same base. 3, I can't break that down at all. But how could I rewrite 81? Nine squared is one option. Ideally, I would like it to be 3 to a power, so it's the same base. So we could write it as 3 to the 4th. So depending on what this was over here, if this was 9 to a power, then we would use the 9 squared. Because this is 3, I want to write 81 as 3 to the 4th. Okay, then we can use those properties. Because both sides just have 3 to a power, you can drop that base and just say the exponents are equal. So x plus 1 equals 4, which means x equals 3. Could you check these if you wanted? Yeah, absolutely. Just grab a calculator, and if you type in 3 to the 3 plus 1 power, you get 81. So it does work. All right, so B, 2 to the negative x equals 16. So 2, I can't break that down. How could I rewrite 16? That means you can drop those 2's and set the exponents equal. So negative x equals 4, which means x equals negative 1.
I'm confused, Mr.
Yes.
Yeah, how is it negative 1?
Negative 4. Obviously.
Yeah, I was paying attention.
Thank you. I divided by negative 1 and okay, C. 1/5 to the x power equals 1 over 25. Thoughts? Okay. 1 over 25 would be the same as if you took a 1/5 to the second power. So then we just get x equals 2. So it doesn't matter if that base is a fraction or not, as long as it's the same on each side. Okay, why don't you guys do D? 2 to the 2x minus 1 equals 4. So you changed what? Made your 4 equal to 2 squared. So then 2x minus 1 equals 2. Add over your 1. Divide by 2. So far, so good? Let's do equals 16 to the x. Alright. Can I write, is 16 8 to a power? No. So I have to change both of these. Both 8 and 16 are powers of what number? 2. So be very careful when you do this. I'm going to put in parentheses. My 8 is the same as 2 to the third. And I'm going to put this negative x plus 14 on the outside for a moment. 16 is 2 to the fourth. Now we have to remember our properties of exponents. When you have a power to a power, what do you do with those exponents? Multiply. So this gives me 2. I have to distribute that 3. So negative 3x plus 42 equals 2 to the 4x. Now what? Yep. Now we have the same base on each side, so exponents equal to one another. So if I add over my 3x, divide by 7, and we get 6. And again, you can always check these just by plugging it back in. So sometimes you might have to change both sides, not just one. F. 3 to the x squared minus 7 equals 27 to the 2x. What will my common base be? 3. Good. So 27 is 3 to the third. I'm putting that in parentheses with this 2x on the outside, because what do we have to do with those exponents? So now we can set the exponents equal. This one is a quadratic, so what do we have to do? It has to be equal to 0 so we can do box method. So we'll subtract over that 6x. Because it's a 1x squared, we could do the shortcut. Multiply to negative 7 and add to negative 6. So if we set each of those equal to 0, we get x to be . And so you might get more than one answer, depending on your problem. Again, if we check them, both of these will work. Okay. Any questions so far? This is really all we're doing today. So we're just going to practice some more of these. Let's look at one that maybe has another step in it. Say I gave you this one. 4 to the x times 2 to the x squared equals 16 squared. Okay. You cannot start off multiplying these things. Order of operations says you have to do exponents before you multiply. The only way we would be able to multiply these together is if these bases were the same. So we have to start out essentially looking at these three numbers, 4, 2, and 16. I need a common base. So all of those are powers of what? Bless you. 2. So my 4 is 2 squared, and that x just stays on the outside. 2 to the x squared, we don't have to change that. 16 is 2 to the 4th. What do you think I do next? Multiply this up. So this is 2 to the 2x times 2 to the x squared equals 2 to the 8th. Now our property says we can set the exponents equal if it's just one thing on each side. So I can't just drop my 2's yet, but if you are multiplying and this base is the same, what do you do with your exponents? Add them. So this is 2 to the x squared plus 2x. So now we can drop the base, set the exponents equal. It's a quadratic, so set it equal to 0. One x squared, so we can do the shortcut. What multiplies to negative 8 and adds to positive 2? So we get x equals 2. Is that one okay? I would like for you guys to try this one. Some number, some base. Our goal is to get the same base. So this is e to the x squared equals e to the 3x. There's nothing I'm going to do with that. But 1 over e squared. I could write that as e to the negative 2 power. If you change floors, it makes the exponent negative. So then, if you are multiplying these e's, what do you do with their exponents? Add them. So that's e to the 3x minus 2. Now, you have just a plain e on each side, so what do we do? Set the exponents equal. Quadratic, so we set it equal to 0. So I will subtract over my 3x, add over my 2. 1x squared, so we can do the shortcut. What multiplies to positive 2 and adds to negative 3? Set each of those to 0 and you get x to be
2.
Question?
No, I just did a different verse one.
What you do?
I just said I didn't add this, I just dropped them.
You got it. Just have to be careful.
Yeah.
So, as long as you recognize when you put it together that you're not multiplying the exponents, you're okay. Alright, I want to do maybe 3 more examples, and then I'm done. I have to have some pretty ones before we finish, though. Cube root of 5 to the negative x equals 1/5 to the x plus 2. So what do you think our common base will be? 5? Okay. How can I rewrite the cube root of 5? That's 5 to what power? 1/3. Okay, this 1/5, you told me you want to use a base of 5. So 1/5 is 5 to what power? -1. Okay, it's looking better already. What do I need to do with these exponents? So that's 5 to the -1/3 x equals 5. If I multiply these, I get -x minus 2. Okay, so set your exponents equal, -1/3 x equals -x minus 2. Add my x over. -1/3 plus 1 would be a 2/3 x equals -2. You can divide by 2/3 or multiply by the reciprocal. And we get x equals -3. So you can handle the radicals as well. You just turn it into a fraction power. Do this. Okay. Can I multiply that 2 times 4 to the 3x? No. You can only multiply those if the base is the same. So once again, I really have 3 things. A 2, a 4, and a 1/64. What could I do? Okay. 2, I don't have to change. That's just a 2 to the first. 4, I would change to 2 squared. 1/64. First of all, to bring that up to the top, it would have to be a negative. And 2 to what power equals 64? So we have 2 to the first times 2 to the 6x equals 2 to the -6. When I multiply these, what do we do with their exponents? So now I can set the exponents equal. So if I subtract my 1, divide by 6, I get -7/6. Are we doing okay with these guys? Last one I want to talk about. I need a common base. 5, can we break that down at all? No, so it has to stay. This has to be 5 to the 2x minus 3. So the question is, how would I change a 1? We can't change the problem, but I need it to be 5 to some power. What'd you say? 0. Remember yesterday we said anything to the 0 power is 1? So I could write that as 5 to the 0. So 2x minus 3 equals 0. Add over your 3 and divide by 2. Alright. That is my stopping point today. I want to talk about just a couple things. Today's assignment there is a handout on Classroom. Only do the odds. So you don't have to do all of them, only the odds. Second thing I wanted to mention, tomorrow we're working with the same thing. I am going to throw a couple inequalities in there, but it's not really going to change things much. So tomorrow, I'm not going to teach for very long, probably 10 minutes will get me through the couple examples I need to do. And then there'll be a Math Excel assignment, and you'll have the rest of the class to work on it. I know my 6th hour, because we have their class will be a little bit shorter tomorrow with PEP assembly, they asked me if I would go ahead and open that assignment early. So I have opened that Math Excel assignment already. I know there's a lot going on this weekend, and some of you might want to get your homework done before the weekend. So that one is open if you have some extra time today and want to start it, and then we will have some class time tomorrow to work on it as well. So Math Excel is open if you choose to work ahead. You know how to do the majority of them